Hi, I'm Andrew Larssen. Thank you for watching my AWS Community Summit talk on how to build and run a secure service on AWS. First, I make no apologies for the cheesy images. I have tried to keep this talk as high level as possible, so I have avoided architectural diagrams. If you want to find out more about any of the specific areas, please join the AWS Community Summit Q&A or contact me. So, a little about me. I am an AWS Partner Network Ambassador and the AWS Technical Lead at PA Consulting. I've been working with AWS for over 10 years. Today I will be talking about building and running a secure service on AWS. I will cover what DevSecOps is and why it is my preferred way of working, what culture you need for DevSecOps to be successful, and also what technology you can use to build a CI/CD pipeline and what you can use to monitor your running workload. So first, why should you care about DevSecOps? DevSecOps is about the safe delivery of business value. If you work for a software company, ultimately your company gets paid not for writing software, but for delivering a service to your users. Securing an application means securing against all threats, including hacking and denial of service. And this is essential to keeping your service online. There are also a few key things to securing an application, and that is both quality and process. So DevSecOps is made up of two components for me, and for it to be effective, both of them have to work. So the first is culture. DevSecOps involves building a very different relationship with your security people to you have in most organizations. It involves having a single team approach. So a lot of people have heard of what is commonly known as the Pottery Barn rule. You break it, you bought it. Well, I think there is a similar rule that applies to the technical team that builds a service. You build it, you own it. Each service should have a team around it. It should include a service manager that is empowered to make decisions and prioritise work. Obviously, this will be within the framework laid down by your company, and this will include things like regulatory compliance. Just as it is an anti-pattern to have different teams responsible for build and operations, it is also an anti-pattern to have a separate team responsible for security. Within your service team, you should have people with the correct expertise to make sure your service is secure, but ultimately, security should be the responsibility of the whole team. Now, in an ideal world, you would have polyglots that could do everything, but that's not essential for DevSecOps to work. Often your security expert may not be an AWS expert, and it will take time and cooperation for them to know what controllers are available and what is the best practice in AWS. By using processes like code reviews, you can gradually build cross-cutting skills, as well as leveraging all the expertise you have. Also, I'm not saying that the makeup of a team should not change over time. You'll probably need far more developers on a team early on in the initial build of a product. But from day one, you should make sure you are thinking about security and operations and have some of those skills within your team. So one common model of security that a lot of people use is the CIA Triad. There are three pillars of security: confidentiality, integrity, and availability. But rather than these being about security, these should be principles when we use to design and operate our service. Take availability, for example. If you want your application to weather a serious DDoS attack, it will be far easier if your application is well built. It will help if your application is horizontally scalable. It will also help if you use a caching layer to offload identical requests. And finally, if you have leveraged your knowledge of AWS and you have used AWS Shield to protect your application. The best solution requires knowledge of application development, operations, security, and the AWS product set, and requires people with a knowledge of all these things working together. Confidentiality and integrity should also be as important to software engineers as to security practitioners. So, moving on to technology, one of the key principles of DevSecOps is using technology to automate security wherever possible. Automation allows you to perform frequent checks as it reduces the cost of testing. By building security into a CI/CD pipeline, it becomes a quality gate. No software passes into your development or production system that does not meet the required standards. If you have already worked with DevOps and CI/CD, you should already be used to this sort of process with unit and feature testing. By building security testing into your pipeline and making it an inexpensive activity, you can bring it earlier in the software development lifecycle, and this can avoid nasty surprises when you leave all your security testing to nearer to the launch phase of an development. Also, this avoids having expensive one-off health checks and that sort of process. So the most important part of DevSecOps technology is arguably the pipeline. It is the automated process that turns code into a functioning service. There's just as there are often multiple testing phases, there can be multiple security phases, including static and dynamic code analysis, dependency checking, evaluation of infrastructure as code, and even pen testing. So, what pipeline to use is a matter of personal preference, and it also depends on the complexity of your project. So all the different pipelines have their advantages and disadvantages. Travis and Circle CI are the most cost-effective and very quick and easy to set up. If you have a complex project with many code bases, you can outgrow them quickly though. Code pipeline, including code build and code deploy, work very well, and I think they do lack something when you're trying to visualize a more complex build process. I've also found that sometimes code deploy won't quite do what I want, and I end up having to stitch things together with Lambda functions. It's great that you've got the ability to do this, but this can add a lot of extra complexity. My personal preference at the moment is for the open source products. The one I'm most familiar with is Jenkins. I have a love-hate relationship with Jenkins, as do a lot of people who use it, but it does have a nice variety of plugins, the ability to manage your pipeline in code, and the ability to create dynamic workers in Kubernetes using a plugin. If you are already using EKS, it can be a great fit. For me, the second most important class of technology in DevSecOps is monitoring. Security is unfortunately an ever-evolving challenge. New exploits are always being discovered. Just because your application passed security checks on its journey through the pipeline does not mean it is not susceptible to newly discovered vulnerabilities. And this can be either in your own code or in some of the libraries you use. You should be monitoring all aspects of your application and looking at trends. Is there a particular resource that is being utilised more than expected? Are users doing something that you didn't expect? All of these can indicate there is a problem with your application. This could be a security problem or maybe a usability problem. Either way, it's important that you diagnose the issue, as it could be impacting your business. In AWS, you should be capturing data like VPC flow logs, CloudTrails, AWS config output, CloudWatch logs, and this is on top of your application logs and your operating system logs. Having all your logs together so that you can look at events that were happening at the same time can be crucial for investigating issues, especially involving security and performance. So what logging product to use? CloudWatch is a good monitoring solution for AWS products, but it has a couple of drawbacks. Its search is a bit primitive, and it is not the best at aggregating multiple logs together. I find using something like Elk can make the logs much more easy to interpret. However, one aspect of CloudWatch that I always use is CloudWatch alarms. They are an essential way of alerting, and this is often the first indication of an issue. Also, you can use Lambda functions to respond to alarms and trigger automated responses to certain situations, thereby building a self-healing infrastructure. If you're looking for a SaaS solution, I have had great personal experience with both Splunk and Datadog. Another critical area is credential management and PKI. So even if all your data is flowing inside a private VPC, it is still best to use TLS for all your internal communication. TLS makes sure the data is encrypted in transit, and it also ensures the identity of the services you are talking to. It is important to have a public key infrastructure for your internal TLS. It is also important to manage the credentials that your applications have access to, storing them securely and having the ability to rotate them. There are two possible routes for achieving both of these. You could use either AWS Secret Manager and AWS Certificate Manager Private Certificate Authority, or my personal favourite is to use HashiCorp Vault for both of these. At the moment, Vault is more feature-rich and supports a wider range of services, and it also integrates very well with both IAM roles and EKS. So one thing that's very important is knowing what you need to secure. You should know about the AWS shared responsibility model. You should also know about the AWS compliance documents available for all their products. One thing to watch out for, though, is the shared responsibility model does change for different products, so it can be slightly different for Lambda and EC2 instances. When it comes to encryption of data at rest, KMS has all the bases covered. There are a few ways to use automation to ensure everything is encrypted. If you're using Terraform, you can use modules with common settings for encryption included. You can also use tools like TFSec to check for encryption. You can also use AWS config to check for anything that isn't encrypted. By using a combination of these methods, you can make sure that you are checking at both build time and at operation time. Another great tool for checking the maturity of your use of DevSecOps is the well-architected framework. The framework is made up of 5 pillars. They are operational excellence, security, reliability, performance efficiency, and cost optimization. All of them are relevant to DevSecOps. Security is obvious, but the others are just as relevant. Decommissioning unused instances will help you remove unnecessary attack vectors, but this one falls under cost optimization. Monitoring, self-healing, and disaster recovery fall under reliability. Automation and process fall under operational excellence. You can use the well-architected tool in the AWS console to assess your own workloads. But if you need additional help, a well-architected partner can complete an assessment for you and will probably be able to offset some of the costs of remediating issues with AWS service credits. Another element of the well-architected framework is game days, practicing your procedures. Not only should you have backups, you should also practice a restore and make sure you have everything you need backed up. You should also test procedures like backups with your infrastructure as code. Things like Terraform and RDS point-in-time recovery can be interesting, and you don't want to find this out in the middle of a crisis. It is always best to design your service so any internal APIs, databases or queues are not available to the internet. Present the minimum attack surface possible. You can do this with a good network design and using either proxies or NAT gateways. Also take advantage of VPC endpoints to keep the traffic within your VPC. Many services like S3 can be locked down so they can only be accessed via a VPC endpoint. This can protect you against leaked credentials or incorrect permissions. As part of your security testing, you can assume that no services are public by default, and then whitelist services that you want to expose. This can help you automatically ensure that nothing is available over the internet that you weren't expecting. So here are some of the security tools I use on a regular basis. I won't cover them in much detail, but I briefly want to touch on a few. So it is crucial to have a dependency checker to check the libraries that you use. It is easy to set up an open source tool, or for a more comprehensive solution, you can use a product like Nexus Firewall. SonarQube is a great tool for code analysis, and it can block a build based on both quality and security issues. It supports multiple programming languages. AWS's Code Guru is continuing to improve, and in review mode it can spot a number of security issues. ECR now has a container image scanner built into it, based on the open source Claire product, and is very good if you use a lot of containers. If you're using Terraform, it is essential to use a product like TFSec. You can evaluate your Terraform against a number of AWS predefined rules, and you can also add a number of custom rules to enforce additional policies. Another tool that I like is the AWS IAM checker. This uses the AWS IAM simulator and can test the permissions assigned to a role. So one important thing when building AWS services is to use lots of separate IAM roles. Try and keep each IAM role as granular as possible and only give it the minimum permissions it needs to do its job. Using separate roles for each application, and also use separate roles for execution and deployment of applications. You will normally find that the permissions that you need to deploy an application are very different to the permissions that you need during the running of that application. One of the approaches I favour is, wherever possible, I like to build a mutable infrastructure. My build pipeline will produce either Lambda zip files, container images, or AWS AMI. I regularly deploy new versions with both application and operating system updates. This allows zero downtime deployments and easy rollback, and it ensures that everything is in a known state. By building assets like this and promoting them through test to production, I can be confident of exactly what is deployed where. We have reached the end of my brief walkthrough of AWS DevSecOps. Using some of these techniques, I have helped improve both security posture and efficiency on projects that I've worked on. I hope you find some of the ideas useful in your own projects. If you have any questions or comments, please join the AWS Community Summit Q&A sessions. I can also be contacted on Twitter and LinkedIn.